All right, here's example 5, section 4.4. So it says a store rents an average of 750 video games each month at the current rate of $5. So already, it's a pretty outdated question. Anyways, however, for every $1 increase, they know that they will rent 25 fewer games each month. Create a quadratic equation in standard form to represent the relationship and use it to determine the minimum number of times the owners should increase the rental rate enough to generate a revenue of $5,400 per month. All right, so there's a lot here. First, let's just make sure we know what revenue means. So in this example, our revenue is going to be basically the number of video games they rent each month multiplied by the price per rental. Right? It's the money that they make, or the money they bring in, rather. So it's the number of games rented times the price per rental. Okay? So if we're writing a revenue equation, we have revenue is going to be equal to the number of games times the price per game. So we have here that they rent 750 games a month. However, for every time they increase the price by $1, they're going to lose $25, or 25 games rather. So it'll be 750 minus 25x, where x is the number of increases, price increases. And then our price is going to be $5 plus $1 per every increase. So here we've said x is the number of price increases. Okay, so to get a quadratic, we'll just have to FOIL these two things together. And what this works out to be is 3,750 plus 625x minus 25x squared. So there's your quadratic. Okay, so now we need to use this to find the number of price increases they need to do to get to $5,400 in revenue per month. So we will say that $5,400 is equal to our equation. And then before we can solve for x, we need to set this to be equal to 0. So we'll move this over. And get 0 is equal to negative 1650 plus 625x minus 25x squared. So you're good to go and use quadratic formula here if you'd like. But right away I see a couple of ways, or at least a way to simplify this equation down a little bit to make it easier. And that is that I have a 25 in front of my x squared, but 625 and 1650 are also divisible by 25. So I'm actually going to divide both sides by negative 25 here to get 0 is equal to 66 minus 25x plus x squared. That's a lot easier to look at. In fact, I'll even rearrange this now to look like, or at least be in the order that we like. So you can go use quadratic formula here if you want. But what I'm going to do is 66, I'm going to use sum and products because 66 doesn't have a whole lot of factors. So you can probably get to our factors pretty quickly here. So a sum of 25 and a product of 66. So 66, the factors are 1 and 66, 2 and 33, 3 and 22, 6 and 11. But right away, 3 and 22, they had to be 25. And if they were both negative, they had to be negative 25. So, and still multiply to be positive 66. So I'm just going to do sum product here, which is a little quicker and certainly less workings, less messy. So 0 is equal to x minus 3 times x minus 22, which gives me x is equal to 3 and x is equal to 22. So our question asked us to find the minimum number of times they should increase the rental rate. So that would be x equals 3. Right, that's the minimum. If they did x equals 22, they would sell less games but make the same amount of money. So, if this was a problem where, you could have stopped and used quadratic formula at a couple different points, but it was certainly, I think, quicker and certainly cleaner to use sum product. But it just goes to show that there are several ways to solve these, right? And it's important that you identify with the ways that you like and get good at you doing those methods. If you can see the sum and the product factoring really quickly, then this certainly was an easy one to do. If you could see the divide by negative 25 step. So as you're doing these examples, you'll see that you don't always have to jump right to quadratic formula. In fact, sometimes it's easier to not.